The goal of this video is to look at how to graph the derivative function given any old function. And since the derivative is related to the slope of the tangent line at any given point, we should probably start by looking at several different slopes of lines so that we can get a sense for the types of things that we're looking for. So let's look at the graph of y equals mx for different values of m. So if m is -3, then we get a negatively sloped line, and we can compare that to -2 and -1, and we can see that it looks like it's getting shallower and shallower as the value goes from -3 to -2 to -1. And then we know when m is 0, we just have a flat line, a horizontal line. And then for positive values of m, we also can look at 3, 2, and 1, and we can see that as we go from 3 to 2 to 1, it gets shallower and shallower. So now let's look at the plan for graphing the derivative function. And there's 3 basic steps. Step 1, look for places where the slope of the tangent line is 0. Those are usually the easiest things to find. Those are the places where the graph of the derivative function crosses the x-axis. Then look for places where the slope of the tangent line is positive, and I recommend labeling those places with a plus sign. The graph of the derivative will be above the x-axis in those places. And similarly, look for places where the slope of the tangent line is negative. Label these places with a minus sign, and the graph of the derivative will be below the x-axis in these places. So here's the plan, and let's look at an example. So suppose we have this function right here, and there's no equation, we're just given a graph here, and we want to try and graph the derivative function, and I'll do it on this set of axes here. Okay, so step 1 here, or the first bullet point here, says look for places where the slope of the tangent line is 0. And so those are usually places that are either maxima or minima, although they could also be what we call saddle points. Those are places that are neither maxima nor minima, but still have a horizontal tangent line. But here we don't have to worry about that. We have a point here that looks like it would have a horizontal tangent line, and then another point over here that looks like it would have a horizontal tangent line. So that means if we kind of trace this down to the graph here, we expect that it crosses the x-axis here, and if I trace this one down, it looks like it would cross the x-axis about there. The second step says look for places where the slope of the tangent line is positive. Okay, so something like maybe right here would have a positive tangent line, and maybe something over here would have a positive tangent line. So it looks like anything over here is positive, so we'll put a plus sign here. And then anything over here looks like it's positive, okay. And so down here, that means that anywhere over here we're going to be above the x-axis, and anywhere over here we're going to be above the x-axis. So, and let's see, it looks like maybe here, it looks like it's getting a little shallower, and here it looks like it's getting a little shallower. It's hard to draw them here. So maybe we have something that's getting closer and closer to the x-axis, so maybe something like this, and then something like this. Okay. And then the third bullet point, look for places where the slope of the tangent line is negative. And we're going to label those with a minus sign. And I think it's anywhere in here we have a tangent line with a negative slope. So I'm going to put a minus sign in here, which means down here we're going to be below the x-axis. And it looks like we're pretty shallow right here and pretty shallow right there. So in the endpoint, so maybe it's going to do something like this, where it kind of goes around like that. Okay, so that's a rough sketch of what the derivative function would look like. If I were to call this function, say, f, I could label this as f prime. And let's look at what the actual derivative function looks like. So it looks something like this. And this looks roughly like the sketch that we had. It's a parabola, more or less. And we can see that we have the 2 places here where it crosses the axis, and it's positive over here, and positive over here, and then negative down here.